Hello again, this is Dr. James Camp from Lee College in Baytown, Texas, and this is my commentary on Chapter 4 of Big C++ by K. Horstmann, Loops. In this Part 1, we're going to cover while loops, for loops, do while loops, and input loops. So remember that program we planned way back in the beginning of this course for calculating interest. In flowchart form, it looks something like this. You check whether the balance is less than the target. If it is, you're going to increment the year and then add interest to the balance, and then it loops back. Okay. This whole program loops back on itself, repeating any statements that are inside that loop shape. Okay. We call a programming structure that executes one or more statements repeatedly a loop because of the way it looks on a flowchart. Now, C++ has three looping statements. While, which is what we call a conditional loop, it continues to execute the statements as long as a particular condition is true. For, which is what we call a counting loop. This is a loop that counts through a series of values to do a particular task an exact number of times, or to do a task once for each letter in a string or something like that that counts through a series of values. Another way of looking at it is that while is an indefinite loop. You have no way of knowing when the program is written or when the program starts how many times the while loop is going to execute. A for loop is a definite loop. You know how many characters there are in a string going into the for loop if it's supposed to count through all the characters in a string, or you know how many numbers there are between 1 and 10 if you're counting from 1 to 10. Okay, the third kind of looping statement is a do while, which is another conditional loop, but it's called a post-test loop. That means you run through the loop once before testing the condition instead of always testing the condition at the start of the loop. Why that's important will become obvious at the end of this lecture. So again, Chapter 1 had this example of an algorithm needing a loop where we start with a balance and a year value of 0, and we count up, adding interest to the balance every year while the balance is less than 20,000. And that's the key phrase, is that we're repeating while the balance meets a particular criterion. So a while loop template in C++ is fairly simple. It says while, you have some parentheses, and there's a condition. This should remind you a lot of the if statement. Okay. In fact, they work very much the same way, except that a while repeats, whereas an if statement only runs once. The condition is going to be a Boolean true-false statement, okay, or a Boolean test, just like the if condition. It's going to be something that evaluates to true or false. And the statements are repeatedly executed until condition becomes false. Okay, so that's a point where I should point out a very common pitfall, is that you can easily write a while loop where the condition never becomes false. And if that happens, the loop will repeat over and over and over and over again until you kill your program in some artificial way, Control C, or hitting the stop button on your debugger or something, because you've created what we call an infinite loop, a loop that has no way of ending. Okay, so let's look at that investment problem. Starting with $10,000, how many years until we have at least 20,000 at 5% interest? Which seems kind of high these days, but may be kind of low for the stock market. You never know. Okay, the algorithm, we're going to start with a year value of 0 and a balance of 10,000. And then we're going to repeat the following steps while the balance is less than 20,000. We'll add 1 to the year value. We'll calculate the interest by multiplying the balance times 0.05, 5% interest. And then we'll add the interest to the balance. And then we'll go back and repeat while the balance is still less than 20,000. And then at the end, we report the final year value as the answer. So here's what the program looks like. We have our standard setup stuff. We set up some constants, a rate of 5, an initial balance of 10,000, and a target of twice the initial balance. We have year equals 0 and balance equals initial balance. Okay, while balance is less than target, that's our key point here, is we're setting up a while loop. We're going to increment the year, and then we're going to add interest to the balance. And we're going to keep doing that until balance is no longer less than target. So if balance ever exactly equals target, that's fine. Or if balance is greater than target, that also would exit our loop. And at that point, we'll know that the number of years stored in the variable year is going to equal the number of years it takes for the investment to double. So we'll output that for the user and move on. And in this program run, the investment doubles after 15 years. Okay. We can trace that and see that we had $500 the first year, a little bit more than that the next year, a little more than that the next year. And eventually we get up to 15 years where we have added enough to break through the $20,000 ceiling. And at that point, the while statement becomes false, and we'll just print out the number 15. Okay. There are a few things I want to point out about this kind of overly crowded figure from the textbook about the while statement. The first is that with a while loop, you have to define a loop variable outside the loop, in fact, before the loop, okay? And you have to initialize it. If you don't initialize it, you don't know that the while condition will ever be met. The second is that you have to define the loop condition so that you define it very carefully so that it's what you want to be true while the loop is running. Okay, it's very tempting to say balance greater than target because that's where we want the loop to end, but that's not. That would be an until loop, and there's no programming language I know of that has an until loop. So you have to think of it as a while loop. While balance is less than target, we're going to keep increasing the balance. You also have to think about it and make sure that your while loop has a way to end the loop. Okay, that balance will eventually become greater than target and the loop will end. Finally, I want to point out that in this loop that we created, the interest variable only exists inside the while loop. It's created each time you go through the loop, and then it's immediately destroyed each time you exit the loop. So be careful about creating variables inside the loop. You should only do that if you're sure that that value is only needed inside the loop. Okay, so take a moment and think about what the output would be from this loop. Maybe take a sheet of paper and write out what the input and what the I value and the output look like after each run through the loop. And here's what the actual hand tracing should look like. So I starts out at 5, and so the output the first time through the loop is 5. Then I becomes 4, and we add 4 to the output. Then I becomes 3, and we add 3 to the output, 2, 1, and at 0, the loop exits because I has to be greater than 0 to run through the loop, so we never print 0. So the final output looks like 5, 4, 3, 2, 1. Okay, now let's look at some ways that we could miswrite this simple bit of code. If we put an I++ inside the while loop instead of an I-, then 5 is going to become 6, and then 7, and then 8, and then 9. But the while loop is while I is greater than 0. We're not counting down to 0, we're counting up. So this creates another one of those infinite loops that I was talking about. Another way to create an infinite loop is forgetting to update the variable used in the condition. In the investment program, that might look like this. We might say while year is less than or equal to 20. We remember to update the balance by adding the interest, but we forget to update the year. And so year is always 1. Year never becomes greater than 20. So the program will just keep adding interest to the balance forever and ever until you find some way to stop it. Okay, here's another common programmer's error. What is the output of this loop? This looks exactly like the loop that we started with at the beginning of our program, except the programmer made the mistake that I suggested earlier about the investment program. They wrote what they want to be true at the end of the loop instead of writing what they want to be true during the loop. So in this case, I is 5, I is never less than 0, so this loop won't even run. There's just no situation where this loop would run. What about this program? This is a very subtle error that often takes programmers hours to find. It's this semicolon here. Now, if you recall that when we did if condition semicolon is read by C++ as if condition do nothing. Similarly, while condition semicolon is interpreted as while condition do nothing. This code repeatedly executes a do nothing statement, but odds are nothing ever happens to the condition, nothing ever changes, and so the loop will never end. This is another great way to create an infinite loop. I can only think of one place where this behavior is useful, and that's something that computer scientists call a spin timer. That's where you're waiting for a time to pass, and so you just spin processor cycles doing nothing while you wait for that time to pass. And so you can say while time minus before time is less than delay, okay, time will actually change. So the while condition will eventually end, and you will eventually exit the while loop. So this is not actually an infinite loop, it's just a do nothing loop that waits for a specific amount of time. Okay, some other common errors. One that plagues programmers from novice to very experienced is something called the off by 1 error. And that is, you need to know if you start the variable for year at 0 or at 1. You need to know, do you run the test for less than target or less than or equal to target? In other words, if the balance is exactly 20,000, does that count? Should that exit the loop? Or should you do it one more time just in case? Now, maybe if you just code some numbers and add a +1 or a -1 here or there until you get the right answer, you can sort these things out. But that's not a very good way to code, and it most likely takes a very long time to try all the possibilities. And this comes back to the saying, another version of the saying that I gave you earlier in our programming lessons. Hours of coding can save minutes of planning. Okay, you can spend hours at the keyboard trying to fix your code that wouldn't have necessarily needed fixing if you had just done a little bit of planning. And so the kind of planning we suggest here is to step through a couple of test cases with pen and paper while thinking carefully about the problem. So consider a really simple test case. We start with $100 and a rate of 50%. Okay, why do we pick those? Just to make the math really, really easy and to keep us from having to do lots and lots of iterations through the loop. So we want $200, okay. At the end of the first year, the balance is 150. Clearly that's not 200 yet. At the end of the second year, the balance is 225. Now we're over the target, we're done. So what should year have started at? We made 2 increments. So year 2 minus 1 increment minus another increment is 0. So it's very clear that we need to start with 0. And this leads to hand tracing as a method of not just planning your work, but checking your work. Okay. To do a hand trace, you write your variables on a sheet of paper, and then you mentally step through each step in your code, writing down the values of the variables as you go. Okay, you're going to cross out old values and write down the new values as they're changed, and that way you can also see the history of your program. Now, one handy way to hand trace is to write out or print out your code and follow along with a marker. Okay, now when I say a marker, I don't mean like a magic marker. I mean something that can mark your place. So you might use a bookmark that you can slide down your code, or you might use a paper clip that you can clip to the side of the sheet of paper and run down your code one line at a time. So consider this example. We start with an in value and a sum equals 0, and we're going to do a while loop where we percent the number by 10, add the result to our sum, and then divide the number by 10. And the output value is going to be the sum of what? Well, we can predict that it's probably going to be the sum of all the digits in n. Okay, but let's hand trace this and see. So we start with the paperclip at int sum equals 0, so we've already set n to 1729 and sum to 0. Then the paperclip moves to the while loop. Okay, is n greater than 0? Yes, it is. So we move on, and the first iteration through the while loop becomes the second line of our little table of values. Digit equals n%10, so that's the last digit of n, that's 9. Sum equals sum plus digit, 0 plus 9 is 9. And n becomes n divided by 10. Remember, n is an integer, 10 is an integer, so we're doing integer division. We don't get 172.9, we just get 172. So we drop the last digit, which is probably what we want in this program. And if we continue to trace the next run through the loop, we get a 2 for digit, 2 plus 9 is 11, n becomes 17. The next run through the loop, we get a 7 for digit. 7 plus 11 is 18. N becomes 1. The next run through the loop, digit is 1. 1 plus 18 is 19. 1 divided by 10 is 0 in integer division. And now n equals 0, so the loop condition fails and we exit the while loop. Okay, and we'll end with the program printing the value of sum, which is 19, which should, if you want to check, be 1 plus 7 plus 2 plus 9. Okay. There are often times where you want to execute a sequence of statements a given number of times, or to count through a series of values is another way of looking at this. You could use a while loop. Okay, let's say we want to do something 10 times, once for every value from 1 to 10. Well, we have to initialize a counter. The while loop is going to check the counter, and then inside the while loop, in addition to printing the counter, we need to update the counter. We need to plus it. Now, you could phrase this as while counter is less than or equal to 10, print counter and increment counter. You could also phrase it as repeat these steps for each value from 1 to 10, and the steps are print the value. C++ has a loop made for, this sort of processing, the for loop, okay? And the for loop that would do this exact same thing looks like for counter equals 1, counter less equals 10, counter plus. You say, what? That doesn't look like anything I've ever seen before. And you're right. Recall our while loop version? There were 3 key tasks regarding the counter. It had to be initialized, it had to be checked, and it had to be updated. And that's why the C language for loop has 3 parts. It has an initialize, a check, and an update. Okay, so again, going back to our count from 1 to 10, though this time they counted from 0 to less than 10 and printed out count plus 1. Is there anything better about that? Well, when we get to dealing with strings and arrays that are 0 indexed, you'll see why most people start their for loops with 0. But for now, there's no reason for you to prefer one over the other. Okay, so this first part is the initialize step. We create the variable count and initialize it to 0. The next step is to check the condition. Okay, count is less than 10. 0 is less than 10, so we'll proceed down into the loop and do the statements. We'll print out count plus 1, which would be 1. And then we end the for loop with the update. Okay, we'll count plus, which means count is now 1, and we'll repeat the loop again for count equals 1. So the initialization code happens once before even checking to see if we're going to enter the loop to set up the counting variable. Oftentimes the loop variable is created here, but you can create it before the for statement if you want. The condition is a comparison to test if the loop is done. Okay, when this test is false, we exit the for loop, just like a while loop. The update is code that's executed after each run through the loop. So the condition is checked before each run through the loop. The update is run after each run through the loop. Okay, immediately before you retest the condition. Okay, typically we see for loops increment or decrement a counter. They count up through values or down through values. But they can also multiply, divide, or even read input from a file. Any legal operation on a variable can be done in the update statement. And then finally, the statements form the loop body. They're the statements that are repeatedly executed until condition becomes false. So when we write for loops, the counting variable is often defined inside the for parentheses. You notice here that for this for loop, we declare int I equals 0. We're declaring the variable or defining the variable and initializing it at the same time. If you do this, the counting variable cannot be used before or after the for statement, okay? It only exists inside the for loop. Here's an example where the programmer forgot about this, where they tried to declare the variable inside the for loop and then wanted to use the variable after the for loop. Now, if the programmer wanted to use I after the for loop, what they have to do is come in here and declare I ahead of time. They can declare I before the for loop and then just initialize it in the for loop. Okay, and then this way I is now available after the for loop and the return I statement works. A for loop can count down instead of up, so you could have your counter minus minus at the end. We've seen an example of that already. The increment or decrement does not have to be in steps of 1. You could do plus equals 2 for your counter. Notice that in these examples, the loop variable is defined in the initialization, which is where it usually should be. Here are some for loop examples. There's a plus plus loop, an I plus plus loop in the first example, and an I minus minus loop in the second example. There's an I plus equals 2 loop that counts 0, 2, 4, 6, 8. Okay, here's one that tries to catch I not equal 9 instead of I less than 9. You're never going to exactly equal 9 if you're counting by 2's, so that creates an infinite loop. Okay. Here's an I times equals 2 loop. We get 1, 2, 4, 8, 16. Okay. And then here's a I++ that runs till string.length. Okay, you can use variables and functions as part of your condition. So you can count up to the length of the string. Okay. Earlier we determined the number of years it would take to at least double our balance. What if we just want to see what the balance of the account looks like over a 5-year period? Okay, this time we know how many times to execute, so it's not an indefinite while loop, it's a definite for loop. The output should look something like this: 1, 2, 3, 4, 5 for year, and 10, 500, 11,025, etc. for balance. Now, this is what that program looks like. A couple of things to notice. We read in years from the keyboard here, and we used that as our condition in the for loop. So you don't have to know exactly what this condition needs to be when you're writing the program. You can always read values in from input. The other is that this time we started with year equals 1 because we're treating because we're going to run through the loop once and then print year 1, and then we're going to plus plus, okay, between years. We're not starting with the plus plus statement like we did last time. Okay. We saw this example a minute ago. Using the not equals 9 leads to an infinite loop because 9 is skipped. So it's generally best not to use equals equals or not equals in a for statement. It's best to make sure your for condition is a less than or a greater than, or a less than equals or a greater than or equals. All right. Our final loop is the do loop. When you run a while loop, the loop's condition test is the first thing that occurs. And if the while loop is not satisfied, if the while condition is not satisfied, you'll never run through the loop. The do loop, on the other hand, has its condition tested at the end of the loop, so you will always run through the statements at least one time. This means that the do loop should only be used when you know that the statements have to be executed at least once, whether or not the loop condition is met. That also means the do loop is probably the least used loop of the three. Okay, what are some cases where we would use a do loop? Getting user input repeatedly. If we want to improve our input validation that we learned last time with the if statement, so that instead of just exiting the program when we get an invalid number, we just keep asking for input until we get a good value, we can do that with a do loop. Okay, the way this do loop is structured, enter a number greater than or equal to 0 is going to be printed at least once, and we're going to take a value from the keyboard at least once. But if or while value is less than 0, we're going to loop back and do this again. And so the user has one chance to enter a non-zero value to start with, and if they do, then we only ask them for input once. I mean, a greater than 0 value, sorry. But if they enter a negative number, we can't take the square root of a negative number, so we loop back and ask for another number. Okay, so this is called an input validation loop. They're very, very useful. Another example of a do loop that I use from time to time is called a menu-driven interface. You want to print the menu for the user at least once. And when I say a menu, I mean we're talking about a string of text that includes type A for add and type B for subtract, or type A to make a deposit, type B to withdraw from your account, something like that. Okay, and usually there's a type Q to quit or type X to exit or something like that. So you're going to do this whole print the menu, ask the user for a choice, get the user's choice at least once, and then if they choose Q, you exit the while loop, and they never got to do anything with your program, they just chose to quit. If they choose something else, then you'll process the user's choice, and then you'll loop back and print the menu again, and they'll get a chance to do something else. But the idea is they're given one chance to see the menu and to type in a choice, regardless of whether their first choice is Q or something else. Okay. So this is a comparison of the flowchart for the while loop and the do loop. The main thing to note, of course, is that in the while loop, you meet the condition first, and if the condition is false, you never go through the loop. In the do loop, you go through the loop once, and then you check the condition, and if the condition is now false, you exit, but you've run through the loop body at least once. Okay, and our last topic for the part 1 of this chapter is processing input. We need to know when we get input from a user when they're giving us good input and when they're done. Okay, one method is to use what's called a sentinel value. So for example, if you're entering grade point averages or salary numbers, things that can't ever go negative, then you could use any negative number like -1 as a sentinel indicating that you've reached the end of the values. Here's what that would look like. Enter salaries, type -1 to finish. Okay, while salary does not equal -1, we'll read in a salary, and if the salary does not equal -1, we'll add salary to sum, and we'll count plus plus. Sentinel values are very useful, but they do make your input look a little weird. 10, 10, 40, minus 1. Well, what we're going to do is we're going to average 10, 10, and 40 and get 20. Sometimes there's not a clear sentinel value. Maybe negative numbers are allowed in your grading scheme, and you're trying to read in a bunch of grades, and you want to know it's possible for somebody to have earned a negative number. So instead, you might ask the user to just hit a non-numerical value to quit. Okay, type Q to quit, for example. CN, if it's expecting a number and it gets a letter instead, is going to fail. It's not going to assign input to the number. It's just going to fail. At that point, if you want to take more input, you're going to have to call cn.clear. And then this strategy only works if you're expecting a series of numeric inputs, okay? And so any non-numeric character such as Q would cause CN to fail. I've seen students try to implement this where they were looking for a series of letters and they were hoping that Q would trigger CN to fail, but Q is just another letter as far as CN is concerned, so there's nothing about, in that case, Q is a sentinel value, not a failure code. Okay, so here's one way to implement this, and that is we use a Boolean variable more, and we set it to be true to start with. Okay, while more, we take a value. If CN has failed, more is false. Okay, else we have a legitimate value and we're going to process it here. And then, but if the user typed Q, then CN has failed, more is false. We exit the while loop and we come down here and we can cn.clear to reset the input if we need to. The problem here is that the loop termination test is in the middle of the loop. It's not really a top or bottom test, and this is sometimes called a loop and a half problem. Okay, using cn.fail this way is disliked by many programmers. Okay, so cn.fail is set when the greater than operator fails, rather than at the top of the loop or the bottom of the loop. Okay, but the input operation itself actually returns either true or false, so we can do this instead. While cn greater value, if the user types a number, we're golden. We go into the while loop and we process the value. If the user types Q to quit, then CN fails. We exit the while loop and we're done with our input. All right. So that hopefully fills your brain with enough information about loops that you can start writing a couple of sample programs. This is a good time to do some practice. You have a car loan for, say, $15,000. Okay, lucky you. You get to buy a cheap car. The annual rate is 6.5%. Okay, so the monthly rate is that divided by 12. So you're going to have to divide that rate by 12 to get your interest on a monthly basis. You're going to let the user enter a suggested monthly payment amount. Okay, that monthly payment should be greater than, say, the car loan amount divided by 60 or something, some really large number. But other than that, they can suggest any payment that they want. Then you're going to determine how many months it will take to pay off the loan at that payment amount. So how do we do this? The pseudocode looks like this. While the balance is greater than 0, okay, increment the number of months. So we go from 0 months to 1 month, or 1 month to 2 months, or whatever. We add interest to the loan, because that always happens first. And then we subtract the monthly payment. Okay. And then if the balance is still greater than 0, we go through the whole thing again. Okay, so that's your first practice assignment. Your other practice is a for loop practice. You want to count to 100 by 3s or by 5s. So you want to let the user enter a number to count by. Okay. You're going to write a for loop that prints each number from 0 to 100 without going over, counting by the number the user entered. So if they type 5, you'll print 0, 5, 10, 15, 20, all the way up to 100. If they print 3, you'll go 0, 3, 6, 9, 12, 15, all the way up. If they type 22, you'll go 0, 22, 44, 66. Okay. You'll never actually reach 100 that way. That's okay. If they type 100 or more, you'll never enter the loop. Well, you'll print 0 and then you'll just quit. All right, so those are your practice problems for this lesson. As always, good luck and happy programming.